Okay, Assalamualaikum and a very good day everyone. So today I will going to conduct this lecture online. So we will going to look at the last chapter in chapter 4, which is carboxylic acid derivative, amides. So after this lesson, you should be able to name amides according to IUPAC name and briefly describe the mechanism of the reactions. We have looked into the mechanism. It is quite simple when nucleophilic attack carbonyl carbon and then state the synthesis and reactions of amide. So students, what is actually amides? So don't confuse with amines. I said it in the class before. Amides, when you have C double bond O attached with NH2 or NR. But in the case of amine, you don't have to put C double bond O. We don't have C double bond O, the carbon directly attached to nitrogen and hydrogen or etc. with our group. So this is what differentiates amide and amine. Please remember it well. So the general formula for amide is RCO, C double bond O, stand for C double bond O, and NH2 or NR. Amides are compound in which a carbonyl group is connected to a nitrogen atom. So it doesn't necessarily to be hydrogen here. It may be R group, yeah, not necessarily hydrogen. Okay, naming of amide can be quite simple and maybe confusing for certain people. So please listen carefully. The IUPAC name is based on the longest continuous carbon chain that include the amide group. Don't leave amide group. So we need to calculate including the carbonyl that attach directly to the nitrogens. We will look into the example after this. So if a substituent is bonded to the nitrogen, the name of the substituent is stated first. Yeah, so we have the substituent in normal carbon chain, but in the case of amide, you will see substituent attached to the nitrogen. So the naming will be quite different from usual. So we will see the example later. So the name of the substituent is stated first, followed by the name of amide. So I'm sure that you still remember how to name carboxylic acid. So it is quite similar. Just you need to replace the oic acid in the carboxylic acid to amide at the end of the name. So for example, if you have ethanoic acid, 1, 2 ethanoic acid, so you have this carboxylic acid group. This is the functional group. So when you have amide, the functional group will be replacing by NH2. So you can see OH will be replaced by NH2. So when carbonyl carbon attached to nitrogen, so we call it as amide. So instead of ethanoic acid, the name will be ethanamide. So look at this example. So you need to calculate the carbon, the longest carbon available, and the carbon should be calculated starting from the carbonyl carbon directly attached to nitrogen. This is the functional group. This is the highest priority in this compound. So you cannot calculate carbon number 1 from here. So the carbon number 1 should be here, yeah, C double bond O here. So 1, 2, 3, 4. So 4, instead of butanoic acid, you call it as butanamide. So there's no substituent here, so the name will be just butanamide. So in this case, you have CO. Don't confuse, CO is not alcohol, not ketone. CO means that you have C double bond O. So C double bond O directly attached to nitrogen. So that means you have amide. So calculate the first carbon from here, C. And then you have 2, 3, and instead of propanoic acid, you change the name to propanamide. Okay, similar to this example, when this C double bond O attached directly to OH, you call it benzoic acid, am I right? So when you change it to NH2, the name will be benzamide. Yeah. It is usual if you need to name a compound that have substituent on the carbon. We usually done that. But if the substituent bonded to instead of that carbon, the substituent attached directly to the nitrogen, for example. So what should we name it? So this is what we call as substituent on the nitrogen, and they should be stated alphabetically. Meaning to say that if you have like this, ethyl, and then you have another substituent here, methyl, so ethyl will come first before methyl because E comes first before M. And the name of each substituent is preceded by a capital N. And look at this N, italic N, yeah, italic N. So before ethyl or methyl, you should put nitrogen like this, and ethyl. Okay, I'm sorry for the handwriting. I don't have pen with me right now. So N, ethyl, and methyl. So you should put nitrogen and italic, and it should be alphabetical order, and it should be capital letters, yeah, not small letters. Capital letters N and italic, and it is before the ethyl or methyl, before the name of the substituent, right? Now we have one example here. So if you see, first you need to find the name of the parent. So you need to determine whether this is alcohol, carboxylic acid, or aldehyde, ketone, or maybe acyl chloride, or even maybe it is an ester. But it turns out when you have C double bond O here directly attached to the nitrogen, so basically the name of the parent should be amide. So you know that the name is amide, but which amide? Propanamide, butanamide. So you need to calculate the longest carbon available, including the amide group. So this is the first carbon. Yeah, the first carbon, 1, 2, 3, 4. This is the continuous carbon. Do not take this one. Do not take from here because this is separated by the nitrogen. So this is actually, if you look at it carefully, this is substituent. So calculate from this carbon, 1, 2, 3, 4. So 4 means that you have butanamide. So the name of the parent is butanamide. So let's see whether they have substituent. So it is either the substituent attached directly to the carbon like usual, or maybe the substituents on the nitrogen. So if it's in the nitrogen, or on the nitrogen, sorry, on the nitrogen, so you need to identify first alphabetical order. The second one, you have to determine you have to put nitrogen before the name of the substituent. So in this case, you have ethyl, and both substituent on the nitrogens are ethyls. So the name would be like this, yeah. Maybe I can okay, never mind, maybe you can see the answer later. So the name would be N, and then comma, N dash diethyl, because the ethyl group consists of 2 ethyl, so diethyl, and then butanamide. And yeah, maybe you can see, I'm not sure why. Okay, previously I mentioned about N diethyl. Even though ethyl is the same group as the other substituent, you have to mention it twice. Diethyl and N, meaning to say that both ethyl at the same N place. That's why we mention N tu 2 kali. N. Like usual kalau kita namakan substituents on normal carbon kan, 2 diethyl, maksudnya dua-dua ethyl berada pada position number 2. So similar goes to this compound. N maksudnya 2 kali ethyl itu berada di tempat yang sama. Dua-dua N boleh dapat Okay, the second example is that similar, but I think the substituent will be different. So you can see that this is separated by N, so you need to calculate the carbon number 1 from here. C, 1, 2, 3, 4, 5. So the name of the parent should be pentanamide. So settle, and then we have to name the substituent. So usually we name the substituent, we determine the substituent last, but we have to put the name in front of the parent name, yeah. So in this case, you still need to mention 2 times the nitrogen, but different side lah tadi N diethyl, for this case, you have ethyl and methyl. So which comes first, ethyl or methyl? So yang datang dulu adalah ethyl. So first you need to write N and then dash ethyl, yeah, ethyl come first, and then you have to put dash again, and then you put N, and then dash again methyl, and then pentanamide. Okay. Now, amide can be classified into three: primary amide, secondary amide, and tertiary amide. If you still remember, we also classify alcohol before. So similar goes to amide. It is very easy to identify. Let's look at the next slide. Now, you can read this slide, but I have one simple identifications how you can determine whether this nitrogen and this amide is secondary or primary or tertiary. So just for example, you have only one carbon attached to the nitrogen, so it will be considered as primary amide. So you look at the nitrogen. So nitrogen can only hold up to 3 bonds. So if one bond attached to the carbon, only one carbon, so it is primary amide. So look at butanamide and ethanamide. So nitrogen attached to only one carbon, so this is primary amide. Okay, secondary amides, when you have nitrogen attached to two carbons. So nitrogen attached to one carbon here and another one carbon here. So of course another one bond will be two hydrogens. Yeah, don't concern about that. If you understand nitrogen can hold up to 3 bonds, you know that the other one will be hydrogen. So only two attached to carbon. So this is secondary amide. So in the case of tertiary amide, of course, all the nitrogens bonded, all bonds has been bonded to all 3 carbons. Yeah, so nitrogen go to the first carbon, second carbon, and third carbon. So this is what we call as tertiary amide. Now, preparations of amide from carboxylic acid. The first synthesis is when you want to synthesize amide. So please generate your own mind map so that you can see clearly the formations of amide, carboxylic acid, other carboxylic acid derivatives. Okay, now preparations of amide. The first one, you can generate it from carboxylic acid. If you still remember in carboxylic acid topic, the conversions of carboxylic acid to amide using amine is very difficult because carboxylic acids are strong organic acid while NH3 are bases. So both undergo an acid-base reaction to form ammonium salt. They can undergo that reaction. We call it as acid-base reactions. Yeah. Now the mechanism is from base and then protonated to form ammonium salt, ammonium ion, and then we have this carboxylate anion. So for the heating will give you the amide and the byproduct will be water. Now, the first one we look at carboxylic acid, yeah, the amide from carboxylic acid. Now, the second one is from acid chloride. So, from acid chloride, we can also generate amides from these reactions, yeah. If you have acid chloride react with ammonia ataupun primary or secondary amines, and it will lead to amide. So, it is do not actually concerns about even it will yield a secondary or tertiary amide. You can identify it later. So you just need to understand that if you have acid chloride react with ammonia or any amine, you will lead to amide. So in this case, we have acid chloride, ammonia in pyridine, and then you will have amide, and then you have the byproduct. So the byproduct will be one hydrogen from the ammonia and Cl from the leaving group of the acid chloride. Yeah. So the similar concept, the mechanism is quite similar if you use other than ammonia, which is a primary amine. So if you have primary amine, the same will go into, the nitrogen will go into this place and kick off this chloride, and then you will have HCl, and then the NHR will get into the compound. So you will basically get secondary amine. So don't menghafal, jangan menghafal. So if you know the concept, you know the attack, all the attack, the carboxylic acid, the nucleophile attack the carbonyl carbon and so forth, you tahulah apa produk akhir dia, ya. Okay, now let's see reactions of amide. First, hydrolysis of amide. So hydrolysis means that we involve water in the reaction. So it is either hydrolyzed in acid or base. I believe that we have looked into it, I think in anhydride, or maybe before this ester, we have hydrolysis in two conditions, acid and base. So the product will be quite different, yeah? Not really significant difference, just slight difference. For example, if you have amide hydrolyzed in water in acidic conditions, you will get carboxylic acid, and you have the amine byproduct. Okay, amine byproducts. So it will exist as ammonium ion, while in base, dissimilar, you have the carboxylate, yeah, carboxylate ion, but you will get a neutral amine instead. So please remember, if you hydrolyze amide in acidic conditions, you will get carboxylic acid and ammonium ion, but in base, you will get carboxylate ion and neutral amine. Okay, so for the first example, you have benzamide react with water, hydrolyze water in acidic conditions. So you will get carboxylic acid. So OH will get into this place and kick NH2. So you will get carboxylic acid, but the byproduct will be ammonium ion. If you react with water, hydrolyze in water in base, so you will get a carboxylate, which is benzoate. So you get benzoate, and you have this group leaving this group, yeah, leaving this group as neutral amine. So you will get CH3 and H2. Yeah, you get one hydrogen from this reagent. So you will get methanamine. Okay, now the most important reactions in amide that I want you to remember, because it is usually come out in the test, reductions of amide. Yeah, reductions of amide specifically by lithium aluminum hydride. So if you still remember, we have a lot of reducing agents. We have NaBH, which is sodium borohydride. We have hydrogen with all the palladium, platinum, and so forth. Yeah, stannum. Okay, that one, all those reducing agents can be used, but not in this case. Yeah, in this case, you just need to use lithium aluminum hydrides, and amine can be reduced to primary, secondary, or tertiary amines using lithium aluminum hydrides. So if you see from benzamide and then you put the reagent and you have the final products, can you spot the difference? Yeah, the difference is C double bond O is changed to CH2. So it means that we have reduction. So in the reduction process, you will get water as the byproduct. So it just simply change C double bond O to CH2 and just kekalkan NH2. And the number of carbon is still the same. Yeah, the number of carbon. Okay, again, I reiterate, the number of carbon still the same. The only thing that is different is C double bond O is changed to CH2 in reducing process. Okay, reducing reaction. The next one is also the most important topic ataupun subject that usually come out in the test. Please pay more attention. And the Hofmann degradations of primary amide. Yeah, the Hofmann degradation, nama pun degradation, means that it will include loss of one carbon. Degrade, yeah, degrade, loss of one carbon. Please remember, that is the carbonyl carbon when primary amide is treated with bromine or chlorine in sodium hydroxide or potassium hydroxide. Yeah, so it is basically mungkin dia akan gunakan bromine or chlorine in sodium ataupun potassium hydroxide. So that is the reagent. You have to remember the reagent to know what kind of reactions they will proceed. Okay, now In the case of Hoffman degradation, they will lose this C double bond O. So if you compare benzamide with aniline here, so you can see that we missing one carbon. Okay, compared to yang previously, we still have that carbon, cuma C double bond O change to CH2. But in this Hoffman degradation, this C double bond O is completely removed, eliminated from this compound. So you will get only aniline, ya. So no longer benzamide, dia akan menjadi amine, aniline. Okay, so this is the reagent and the byproduct will be sodium carbonate, ya, because the carbon tu tadi dah keluar, dia akan combine dengan sodium, so you will get side product sodium carbonate. And then this is also important, dehydrations of amide to nitrile. So dehydration means that you need to remove water and dehydrate. So usually in this case you use phosphorus oxychloride POCl3 or phosphorus pentoxide P2O5 can be used as dehydrating agent. So this poker ataupun POCl3 or P2O5 act as dehydrating agents to remove water from the reactions. So what they do actually is this H2O is eliminated from this reaction. So if you see hydrogen 2 come from this part and oxygen, and then when it remove, you have to make sure that C still have 4 bonds, so you will get triple bond instead, C double bond N. So the mechanism is quite complicated, but we are not going to discuss in detail here. Just remember that in this process you lose one molecule of water and you will get nitrile. So from amide you can get nitrile from this dehydration process. Okay. Okay, reactions with nitrous acid. Amide react with nitrous acid, HNO2. It will give you carboxylic acid and nitrogen gas. So this reaction is not significant as the product can be produced by other methods, because we have another method to produce carboxylic acid, am I right? So we have learned a lot to produce carboxylic acid. So this is just another alternative to produce carboxylic acid, but it is not preferable and it is not really significant. You just need to know that if you react amide with nitrous acid, you will get carboxylic acid and nitrogen gas as the byproduct. Okay, I believe that that's the end of this topic, chapter 4 topics. And if you want to test yourself, do not hesitate to join quizzes through this game code, or maybe you can just try to do a tutorial that is given on Google Classroom. If you have any questions, do not hesitate to contact me personally. Thank you so much.